So that campaign begun by a wonderful young lady, Claire Oliver, led to what I think was really a fantastic partnership to bring about change. It was a partnership between Claire, other members of the community, Cancer Council Victoria, Sunsmart and Peter Mack to bring about change. And that campaign has subsequently been taken up in what I would call a new dawn for melanoma prevention by someone who's joined us tonight, Jay Allen. Jay, would you mind standing up, please? He'll be joining us after on the panel after the break. Jay has, with Claire's initiation, taken this to another level. He has managed to convince the New South Wales government to ban solarium use, the most obvious preventable cause of unnecessary UV exposure. Not only that last Thursday, South Australia have also announced a ban on solarium. So I just like a round of applause. So we have a new dawn in prevention, but there are other strategies as well. There's early detection, and this is actually a complicated area that remains controversial in the field as to how to detect melanomas early. But one thing I think that is very clear, and that is awareness. Australians, when melanoma is resected on average in Australia, it is much thinner, a much smaller tumour than any other country in the world, and that is because of awareness. There's Claire there on the left, Scott Kirkbride in the middle, a talented young golfer from Western Australia, sadly lost his life to melanoma, and of course we have these wonderful campaigns run by Sunsmart and the Cancer Institute New South Wales and other groups that have raised awareness about this disease so that people know about the disease. So early detection, get those tumours out before they have a chance to grow and spread, is certainly part of reducing the mortality. So how are we doing with all this? Are we winning? So this is data, Victorian data, which shows you the rates of melanoma for men and women. Up the top, men aged 60 plus, in the middle, aged 40 to 59, and then on the bottom, less than 40, men on the left, women on the right. And as you can see, we've got a problem because older people, the rates of melanoma are actually going up. However, for those of you with very good eyesight, you'll see that down the bottom, the rates are actually falling in those less than 40 years of age. And this is in distinct contrast to some other places in the world, such as the United States, where the rates in young females actually increasing. Why is this occurring? I think this is most certainly due to the prevention strategies in Australia that now for young people are starting to have impact in reducing the rates of melanoma. So early detection, awareness and prevention from UV can have some impact. But I'll put it to you, we do need more than that. Unfortunately, melanoma cells have a capacity to spread. There will always be melanoma cells that, despite our best intentions, will get away from the skin, and we need ways of treating them more effectively when they're spread, and that is improved treatment. So how do we go about doing this? Well, at Peter Mack, we deliver our cancer care in multidisciplinary teams. This is actually photos of our multidisciplinary melanoma meeting on a Friday morning. We have many different types of cancer specialists in the room, and very importantly, a number of researchers attending the meeting to inform the way we treat our patients and also to learn about the way we treat our patients to go and investigate the next area of research. One area where we're doing this is in the cutting-edge DNA sequencing. So this is a machine, next-generation sequencing machine at Peter Mack, where we take DNA from patients and we can sequence every single gene in the melanoma from our patients. Every single gene. So what are we finding from these sorts of experiments? Well, we're finding some challenges. And these are data, it's a complicated slide, don't worry about all the details, published by Professor Mike Stratton from the UK. And our findings are very similar to Mike's, and that is that melanomas have 5 times the rate of gene mutation than any other type of cancer. That's a challenge. 4 times the rate of lung cancer, which we know is a challenging cancer to treat, and 10 times the rate of mutations compared to ovarian cancer. So we have very frequent gene mutations in melanoma that create a challenge. But these gene sequencing projects have uncovered some very, very useful information. In fact, one of them has really been perhaps a breakthrough. One's always careful about using the term breakthrough cancer, the identification of a gene mutation of a protein called BRAF that makes melanoma cells grow. So a group in California devised through very clever structural-based drug design, where they solved the structure of this mutant protein derived from melanoma cells, made a drug to turn it off, and you can see on the right melanoma cells growing in a dish, those little dots in a round circle. You treat them with this drug that turns off BRAF, and those cells die and they will not proliferate. So gene sequencing can uncover new targets for therapy. How does this work though in patients? Well, it really works quite phenomenally. This shows a patient with a PET scan that has melanoma in their liver. So that big green and red mass there in the middle of the top is melanoma growing in the liver, taking up glucose, which is what was measured on the PET scan. 2 weeks after this targeted treatment, complete disappearance of glucose uptake as those cells are dying. Very dramatic treatment, and now we know beyond any doubt extends survival, almost double survival in patients with very advanced melanoma. So this has been a significant advance in the treatment of melanoma. But we have problems, and that is that in most patients, the tumours after a period of time start to grow again after this treatment. And there's PET scans there on the left. You can see, if you compare the left middle to the right, there's a great response initially in 15 days, but later, weeks, months, occasionally years later, tumours can regrow due to finding resistance to the drugs. And working with others, we've identified one mechanism of that, which is the acquisition of a new mutation, another gene getting mutated called NRAS, and we now have clinical trials underway to turn off NRAS signalling in these cells for treatment that are successful. So we've teamed up with many groups around the world to now publish a number of quite seminal research articles about this new idea of targeting BRAF, which we think is another dawn of a new era. We had a dawn of a new era in prevention, and now we've got the dawn of a new era in therapy. Now, often I'm asked, well, how are we going to afford all these fancy new treatments, Grant? Well, the answer is we need to treat the right patient with the right drug and not waste expensive drugs that are not going to work on individual patients, so-called personalised medicine. So 50 out of 100 patients with melanoma, their melanomas will have this BRAF mutation. So if we were to treat patients without first testing for this mutation in their melanoma, if you treated 100 patients, 45 out of 100 would get some benefit from the inhibitor. However, strikingly, if you test the mutation first, select the patients most likely to get benefit using the test, 45 out of 50 will get very substantial clinical benefit. And that is so-called precision medicine, personalised medicine, and we hope that's the way of the future that's going to make these treatments a lot more affordable. Now, what other sort of research is going on at Peter Mac? Peter Mac led a very important clinical trial, and it was co-led by Professor Michael Henderson, who will join us after the break. And this was to examine the role of radiation treatment in patients that had melanoma and spread to lymph nodes. Because for a long time, it hasn't been clear what benefit you get from radiation. Some people said yes, it's good, others denied that. So Michael led an Australian trial where people were randomised. Half got radiation and half got observation. We thought this a very ethical trial because we really didn't know what the best treatment was and what were the outcomes. Well, it showed us in the red line there that your chances of getting melanoma growing back in the lymph nodes were much lower if you had radiation. Real world-leading research defining clearly once and for all the role of radiation in the treatment of melanoma. We also have another very exciting new area of research happening to treat melanoma, and that is unlocking the immune system and turning our body's immune system to fight the melanoma. And the example, there's a number of examples of this being tested, but the one that's had most traction so far is an antibody called ipilimumab. We call it IPI for short because it's an awful name to have to say. And it turns off a molecule that is involved in immune regulation that makes T cells, the immune cells that are most important in fighting our cancers, increase in number and attack the melanoma. And this has also been very successful. To show you one example of that, one of the most feared consequences of advanced melanoma are brain metastases, And you're turning the immune system on here, you can see on the left compared to the right, that white mass disappearing after immune-mediated treatment, turning the body's cells, the normal cells, immune cells in the body to fight the melanoma. And this is a very promising treatment. Later this year, together with some collaborators overseas, we'll be doing the first trial in the world to combine the BRAF together with this ipilimumab treatment for the immune system, because we think those combination treatments might be the way of the future. So how are we going to make advances in this disease? A few people will know we had a little ride on the weekend. It was just over 200 kilometres, the Ride to Conquer Cancer benefiting the Peter Mac. As one of my patients pointed out to me last night when I told him that there was 2,800 metres of climbing involved in this ride, that is in fact sea level at the top of Mount Kosciuszko. So I'm in absolute awe, particularly about patients and cancer survivors that did this arduous task on the weekend. But this is a number of our melanoma team and supporters that rode on the weekend. To beat this disease and reduce mortality, we need a team approach. How do we do that? We collaborate with other melanoma centres to collect clinical data and understand the disease. A project called the Melanoma Project, a number of people here tonight involved in that. We do sophisticated high-throughput drug testing. We do molecular imaging. In the bottom left, molecular pathology, find those mutations that match the drug to an individual patient. We do clinical trials on the right. And a real area of leadership, and joining us after the break will be Dr. Claire Fideli, who uniquely can take a single melanoma cell from a patient and grow it in a mouse to study the biology of melanoma. Real cutting-edge remarkable technology. So to make advances, I put it to you, we need a team approach. You're part of that team. It needs to be a global team. We need the community involved, the scientists and healthcare professionals at Peter Mac and elsewhere. Industry is very important. We need the resource of industry, particularly for these new drugs, which I really do believe can reduce the mortality from melanoma. And of course, government has a key role here as a part of the partnership as well. So thank you very much, and I'll hand back to Mel.